Morning, class. Good morning, Professor. Okay, settle down. I'll cut to the chase. My name is this, and today's lecture is about Newton's first law of motion. Now, spit out all the information you know about the great scientist, Sir Isaac Newton. Physics would have been a lot easier if the guy sat under a coconut tree rather than an apple tree. Calm down. I appreciate your sense of humor, Mr. Guy Wild, but do you realize that the global scientific discoveries and new theories wouldn't be able to evolve if Sir Isaac Newton hadn't drafted his three laws of motion? Fine. Anyway, the definition of Newton's first law says this: a particle continues to exist in its state of rest or uniform motion until and unless an external unbalanced force acts on it. Understand what that means? No.
I did. The law means that only an external force can change the state of motion of the particle.
Well, maybe she did, not us. Well, that means that when an unbalanced force acts on a body, it changes its state of motion from rest or vice versa. Let me repeat this. When an unbalanced force acts on a body, it changes its state of motion from motion to rest or from rest to motion. Now, this puts forward an important question. What really is force? To put it in layman's terms, force is a push or pull that can change the state of motion of an object. Now, every object in this universe is stubborn. Every object tends to retain its original state. It opposes the tendency to change its state of motion. This is something we call inertia. Now, anyone got any examples for inertia?
When we turn off the fan, it still rotates for a while. This is an example of inertia.
Well, that really is a perfect example for inertia of motion.
Inertia of motion?
Oh, I almost forgot. Inertia comes in three types: inertia of motion, rest, and direction. Now, inertia of motion is the resistance offered by a particle to change its state of uniform motion. It basically says if an object is moving, it wants to keep moving and is extremely, frustrated by an external force trying its level best to stop it from moving, such that it offers its inertia or resistance to stop it. Now, switching off a fan is a great example of inertia of motion. And other examples for inertia of motion include the forward jerk experienced by passengers when a bus suddenly stops. Now, even athletes run long distances before doing their stunts because of inertia of motion. Now, on to the inertia of rest, which is basically inertia of uniform motion, replacing the word uniform motion with rest everywhere. Unlike uniform motion, where the body is in uniform motion, continues to keep moving in uniform motion and offers resistance to stop it from going into rest, the exact opposite things happen here. The body is in rest and a force is trying to put it in motion, and the body offers inertia to oppose the external force trying to put it in motion. Basically, this whole concept of inertia basically says if a particle keeps doing something, it wants to keep doing something and doesn't want to change. Looks like every matter in this universe is kind of old school, eh? Okay, that was a bad joke. Anyone got any examples for inertia of rest?
Professor, the dust particles fall off a blanket when it is given a jerk.
That's a great example. I told you all about the forward jerk when a bus stops. Well, we all do also experience a backward jerk when we are in a bus that suddenly starts. This is also an example of inertia of rest. Now, on to the final type, inertia of direction. It's the inertia offered by a body to change the direction of motion. To oppose the change of direction of motion, it tries to remain in the same direction it was moving in. Same here. While inertia of uniform motion, the particle just wants to remain in uniform motion. In inertia of rest, the particle just wants to remain in rest. and and an inertia of direction, it wants to move in the same direction it's moving in. Now, anyone got any examples for this one too?
When a car takes a sudden turn, the passengers get thrown outwards.
Excellent. Now, if you imagine yourself tying a rock to a thread and rotating it, if the thread, just imagine the thread suddenly breaks, it flies off in a tangential direction. This is a perfect example of inertia of direction. Now, before you all leave, just note down that the SI unit of inertia is kilograms and is measured in mass. Noted it down? Okay, now it's quiz time. Question 1. What does Newton's first law of motion describe?
Newton's first law of motion describes that a body continues to be at rest or uniform motion until an unless external force acts on it.
Bravo. Now, question number 2. Define force. You? Push or pull. That is correct. Now, question number 3. What are the 3 types of inertia?
Inertia of rest, motion, and direction.
Amazing. Now, Mr. Guywild, what is the dimensional formula of inertia? Oh, come on, man. It wasn't a lecture. Well, anyone who knows about the unit of inertia would easily tell that the dimensional formula is m1, L0, and T0. Oh, bell. Wait. No, the bell doesn't dismiss you. I do. Before you all leave, don't forget to like, share, and subscribe, and comment your doubts if you have any. I'll be sure to answer your doubts in the comment section below. Okay, class dismissed.